Hi students, today we're going to be continuing to solve log equations, but I'm going to show you 3 new tricks to add to your toolbox to be able to solve equations. The 3 rules we're going to learn are going to be called log properties because they help us to understand what operations we can do with logs to be able to manipulate equations. So here are the 3 rules we're going to be learning today. The first thing is if you ever have logs of the same base, and they are being added together, you can then combine them using multiplication. So if you think back to your exponent rules, this kind of makes sense. If you remember that when you are multiplying and you have exponents, what do you do with them? That's right, you add them. You know that this would be 2 plus 3, which would be 5. So that would equal x to the 5th. So this is the same rule, just logs and exponents are inverses of each other. So when you're adding logs, you can multiply their arguments together. So an example of this would be if I have log, which is base 10 implied, 4 plus log of x, I can, since they're being added together, I can multiply the arguments together to be log of 4x. Okay, so that's rule number 1. Rule number 2 is called the quotient property. If I have logs of the same base and they are being subtracted, I can then divide their arguments, which again makes sense if you think back to your log properties. If you have x cubed divided by x squared, I know this is the same thing as subtracting. I would subtract 3 minus 2 to just get x. So this is that same property in inverse. So an example would be, let's use natural log. So natural log of x squared minus natural log of 4 is going to equal the natural log of x squared divided by 4. So anytime I'm subtracting, that will turn into division to be able to condense that down. Okay, the last rule is called the power rule. And if you have an exponent in your argument, you can put that up front to be multiplied times the log. So these 3 properties will help you be able to manipulate equations. And first we're going to practice expanding. When I say expand, I mean we're writing the longer version. And we're going to practice condensing. That means condensing it down to 1 log. I need to do an example for you on this one. For example, let's say I have 2 log base 2 of x. Then I can just rewrite that as log 2 x squared. This can become the exponent in the argument. All right, so let's practice putting those properties into use. First, we're going to be expanding. So what you're going to be doing is you're going to be trying to take this condensed form and go backwards and expand it out for using all 3 of these properties. Notice for my first example, they're all multiplied together. So each time I have something multiplied together, I can turn this into an addition. So the bases all will be of base b. So I have log base b of 5 plus, because I've got another multiplication now, log base b of j plus log base b of k. That's it. I'm expanding it out to use this first product property. All right, this one is going to use all 3 properties. So first, notice at the top I have multiplication. I have 5 times x squared, so that will be my first property. So log base 6 of 5 plus log base 6 of x. Now this would be an x cubed. Keep in mind, because it's an exponent up here, I can use the power rule and bump it out front to be multiplied times this log. We usually don't put it multiplied at the end because that confuses it, but if you put it out front, it looks more like multiplication. That's why we put it out front, just for readability purposes. Last, we have divided by here, so using the quotient rule, I'm going to subtract log base 6 of y for that last one. So that is fully expanded out. I put it all in the expanded versions. All right, let's try a couple more examples. I have multiplication in the numerator and I have division down here. So natural log of 3 plus natural log of x for multiplication Now I'm going to subtract because it's being divided by natural log of x, and that exponent I can put out front as multiplication. All right, you try the last one. All right, you should have put a subtraction sign in between the two natural logs. The exponents you can put out front when we expand it out. All right, I'm going to do condensing now. On the back, I'm going to show you a few more specialty examples of expanding and condensing, but I want you to get the basic concept first. So let's go the other direction now. Now we're going to try to condense it down into a single log, the most simplest form. This is used the most when we're going to be solving equations in a minute. So this is the most helpful to be able to for sure know how to condense it down. So I want to combine this into a single log. And notice we have an addition sign. So according to the product property, that means that I can combine them using multiplication. So this can turn into log base b of 6 times x. I can multiply their arguments together. Okay, look at this one. I have addition and subtraction. So 4 times y, because these are multiplied together, divided by, because of the subtraction, the z. So that's how you would condense it down. Notice this rule will only work if all of the bases are the same for all of these properties. So that's a very important feature to look for. They have to have the same bases. And all of mine have the same base. All right, so this 2 out front, remember we can kick that up to be an exponent when it's multiplied out front like that. So that'll be x squared if I bump it out. This is divided by, with the minus there, y cubed. And a lot of people want to put this on the bottom because it has an addition, but it's going to go in the top. Anytime it's a positive term, it will go in the numerator. And anytime it's a negative term, it'll go in the denominator. Because remember that I could rearrange these in any order. Addition and subtraction, the addition could be moved out front. So really, anytime you have a positive term, it'll go in the numerator. Any negative terms will go in the denominator. Okay, so now you have the general idea of how to use the 3 properties that we have. On the back, I'm not going to work all of these, but if you need some extra practice, I posted the full key on my website so that you can get some extra practice if you're still not getting the hang of these. But I want to point out a couple special ones that I thought were a little more challenging. Look at this example right here. This one has 2 in the denominator, and this goes back to the rule I was just saying. Remember, any term that's negative is going to go in the denominator, and any term that's positive is going to go in the numerator. So I want to do this example for you. So we're expanding out. So this 6 is going to go out front. All right. Now I have a division, so I'm going to subtract natural log of x. I'm going to bump that 4 out front to multiplication. And then you can think of this as 2 ways. This whole thing, I'm going to erase this so I can make this a little bit neater. This whole thing is being divided, right? This whole thing is being subtracted. So if you want, you can say, okay, it's this times this, ln y, bump the 3 out front. Okay, this whole thing has been divided. But when I distribute my negative out, it then will become 4 ln x minus 3 ln y. So you can see that it's going to end up being anything in the denominator is going to be a negative term, and anything in the numerator will end up being a positive term. So you can kind of see those 2 ways of thinking it out. Okay, one other one. I thought this was an interesting problem. Go ahead and expand it out, and I want you to see if there's anything you can simplify after you expand it out. So we have a base of 7 here, log base 7 of 49, times, so I'm going to turn that into an addition, and then that 6, I'm going to bump it out front to multiplication, minus log base 7 of k, and that exponent I'm going to bump out to multiplication as well. Okay, now look at this. Is there anything we can simplify? You should be looking at this part right here. What is log base 7 of 49? Did you get it? Should be 2, because 7 squared is 49. So we know that this whole thing can reduce down to just 2. So I can go ahead and replace that to simplify it a little bit. All up to this point we've had variables, so we haven't been able to go any farther. But I thought this was interesting because we can actually simplify this one step. So be looking for those fun simplifying ones. Let's do one of the challenging condensed problems. Look at the very last one. The rest of these I think you can conquer based on what we did on the front using your properties. Of course, this is an interesting one too. You should try this one. I'm going to scoot over here to example F. And thinking back to this example I just showed you with the 2, I want to see if you can think backwards now. Okay, so notice on this problem, we were thinking 7 to what power is going to equal 49? Notice here, all of these have a log base of 4. So I need something with a log base of 4. So I'm looking for this missing number. I need 4 to the 3rd power, because this is my answer, equals what? That's 64, because this would evaluate to 3. So you can also use that property backwards. Now, I'm wanting to condense this down, so I'm going to go ahead, I'm going to kick the 1/2 up. Keep in mind that something to the 1/2 power is the same as square rooting. So this is the same thing as the square root of x plus log base 4, and this 1/2 power is on the y as well, the square root of y. Okay, now I want to condense this all down. So everything has a log base 4 now, and 64, and I have 2 square roots. I have the square root of x times the square root of y, so I can put them together because they're being multiplied together. So that was a little bit of a tricky one, so I wanted to talk that one through. Okay, our final thing that we will do together today is solve a few equations now using our new log property rules. So we have some more tricks up our sleeve now. So looking at this first problem, I cannot rearrange this into exponential form until I condense it down. So now you can see why that condensing rule is really important. I want to combine these logs. Notice they have the same base. They have a base 10 that is implied here. And they are being added together, which means I can multiply their arguments together. I can rewrite this as log 8 times x, we write as 8x, equals 2. Now we have an equation we can solve. Remember, we can convert this into exponential form. So base is 10 squared. Base stays the base, the others switch place. Now I can solve this equation. I know that 10 squared is 100. Divide that by 8. 100 divided by 8 should be 12.5. Or you can reduce the fraction either way. I'll take a fraction or a decimal answer on those. Very good. And also 12.5 you should be able to plug in. Notice if this was a negative answer, it would be no solution because we can never have a negative argument. Don't forget that we talked about that last week when we were solving law of equations. Be looking out for any negative arguments. Those are not valid solutions. Okay, I see I need to condense these logs down. Notice it is subtracting. So I'm going to go ahead and use the quotient property. This is going to be x plus 1 divided by x, because it's subtracting this time. Okay, now remember last time that if we had bases the same on both sides of the equal sign, we could drop these bases. Just like with our exponents, once we get the bases the same on either side of the equal sign, we can go ahead and set the arguments equal to each other or the exponents equal to each other in exponents. So because I have log base 6 equals log base 6, those can be canceled out. So to solve here, I want to get rid of this fraction. I'm going to multiply by x on both sides. and I am left with x plus 1 equals 29x. So I'm going to subtract x to be left with 28x and divide by 28 to get x alone, and x is equal to 1 over 28. All right, let's try another one. Again, notice I am subtracting here. This is a very similar problem to this one I just worked. So I will work it silently while you are working it silently, and we will see if we arrive at the same place. All right, I got 22 over 4, which is squished down there, and I reduced that to be 11 over 2. Did you get that? Y'all are so good. Okay, last solving equation that we're going to do together. I am subtracting again, so I'm going to condense these down. Divided by x plus 3. I have natural log equals natural log, so I can cancel those matching bases. This is very similar to the problem we just worked. I'm going to multiply by the denominator because I would like to get x plus 3 out of the denominator. So I'm left with 2x squared minus 10 equals, and I'm going to go ahead and distribute this, x squared plus 3x. Okay, I'm left with a quadratic. Or I think after I subtract this, I'm going to still be left with an x squared, which means I'm most likely going to need to factor to be able to find the solutions. So I'm working to get it equal to 0 to be able to solve. So I'm going to subtract x squared, subtract the 3x, bring down the negative 10. It's now equal to 0. Okay, so I'm looking for two numbers that multiply to negative 10. And add to negative 3. I know that x times x is going to give me x squared, so I just need to find those two magic numbers. So negative 5 times 2 is going to give me negative 10, and negative 5 plus 2 is going to give me negative 3. So those are my factors. Therefore, my solutions are 5 and negative 2. I'm going to check and make sure this doesn't cause me to have a negative argument. And I can see right here, when I plug in negative 2 here, I'm going to have a negative argument. So this is an extraneous solution. I need to cross that solution off. It does not work. 5 works, works, and works. I'm going to end up with a positive arguments for all of those cases. So 5 is our only valid solution here. All right. So that is how we are going to be using our 3 new properties to be able to solve log equations. Your assignment this week, you will have some expanding and condensing, and you will also have some solving equations. And that will wrap up what we are going to be learning for solving logs. Y'all have done a great job of this. I'm really proud of you learning logs all remotely. Y'all are doing great work. Keep up the hard work.